An object drifts through our solar system, an emissary from interstellar night named 3IATLAS. We thought the mysteries about it were over. We were wrong, because new images, new informations captured in fleeting moments by the James Webb Space Telescope reveal something profoundly weird. Is 3IATLAS flat? And these unsettling revelations arrive just before it goes behind the sun. Each new frames, each pixel, each new discovers forces us to confront with many possibilities. Prepare yourselves. We'll now uncover what 3IATLAS did to plunge the world into confusion. Consider this moment suspended in the quiet flow of cosmic time. In all the centuries of human watching, through every sleepless night of telescopes and patient tracking, only 3 times have we seen an object drift into our familiar solar system from the vast unlit gulf that lies between the stars. 3 fleeting crossings. The most recent bears the name 3IATLAS, not merely a tumbling shard of stone, but perhaps an emissary from deep time itself. Picture it now, a frozen relic, possibly 7 billion years old, nearly twice the age of Earth, carrying inside its core the chemical memories and isotopic fingerprints of an epoch before our sun was even born, before it gathered itself from the haze of an interstellar cloud. Its arrival should have been a symphony of discovery, a chance to touch, across unimaginable distance, the primordial matter from which all stars begin. We remember the first one, Oumuamua, discovered in 2017, a brief spark of intrigue, an elongated form accelerating in ways no comet should, vanishing as swiftly as it appeared. Then came 2I Borisov in 2019, more familiar with its cometary tail, yet undeniably foreign, confirming that our solar system swims in a greater galactic sea. But 3IATLAS, from its first detection by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, already whispered of something stranger. Ironically, the system designed to guard us from internal threats found a messenger from beyond. Its light hinted at a deeper complexity, a pattern that felt deliberate, composed, unsettling. The moment for our closest, clearest view approached. As 3IATLAS traced its hyperbolic path, inward calculations from the Minor Planet Center marked a close pass near the orbit of Mars, early October 2025. It was more than another coordinate on a chart, it was a golden window, a perfect geometry. Earth's position made direct observation difficult, but at Mars our robotic eyes already waited the Mars Reconnaissance Orbiter circling high above the red dust, carrying instruments of extraordinary precision. Chief among them, HiRISE, the high-resolution imaging science experiment capable of resolving details on ATLAS mere meters across, even from orbital distance. Imagine trying to read the license plate of a car from low Earth orbit. This was not just about sharper photography, it was about seeing the truth of a visitor from another star. Could HiRISE catch patterns of outgassing? Could it reveal unnatural symmetry? Perhaps even a super-flat shape beneath the coma, for scientists chasing the origins of worlds' interstellar chemistry and the unsettling possibility of artifacts. This was a sacred encounter, an unopened manuscript drifting toward us through the dark. The data promised by MRO and HiRISE held the power to rewrite our cosmic story. Yet just as this window opened, the world blinked. On Earth, the United States government shut down. Funding froze, operations paused. The long-anticipated public stream, the live feed of this encounter, fell silent. At the height of observability, when HiRISE might have been capturing defining images, our connection to Mars was severed. We, the watchers of Earth, were suddenly blind. Was it simply tragic timing, the machinery of politics colliding with the orbits of worlds, that remains the official plausible story? But to many, the coincidence felt sharp, almost too aligned with the object's moment of greatest exposure. One can picture the quiet frustration within the control rooms at JPL monitors, humming screens frozen, perhaps the most extraordinary images ever taken, now locked behind bureaucratic firewalls. The HiRISE team confirmed they had recorded good data on October 2, 2025, but the principal investigator, bound by policy, could not speak further. Good data? What does that mean in this context? An image confirming a natural comet or something geometric, deliberate demanding containment. The shutdown provided a perfect shield, a lawful silence. And this quiet was not only American. Other spacefaring nations, China's CNSA, Russia's Roscosmos, the European Space Agency, remained cautious, subdued. An interstellar object within reach is a global event beyond politics. Surely their telescopes, their tracking networks would rush to fill the void, but they did not. ESA eventually shared lower resolution footage from the ExoMars Trace Gas Orbiter, but the global response lacked the electric joy such a discovery should ignite. Where were the independent confirmations, the competing analyses, the celebration of a new era of interstellar science? Instead, a strange shared silence, heavy, careful. Perhaps they too saw something difficult to explain, or perhaps they chose not to speak, bound by an unspoken agreement, the kind that protects order when knowledge becomes dangerous. Some remembered the warning of Jeremy Corbell months before, a big lie, a deception moving slowly toward us. Was 3IATLAS that deception, or merely the silence itself? Whatever the truth, the blackout changed everything. What began as a study of an interstellar traveler became a question about what we are allowed to know. The darkness around Atlas only deepened its mystery. The puzzle pieces scattered before the silence began to form a shape that no comet should have a silhouette too clean, too deliberate, too aware. The silence that followed was not ordinary silence. It was the kind that carries weight, the kind that reshapes meaning. When our window onto 3IATLAS closed abruptly and inexplicably, during its closest passage to Mars, the story itself changed form. What had begun as a scientific observation and exercise in trajectory reflectivity composition quietly transformed into something else, into symbol, into myth, into doubt. In the days that followed, the object ceased to be only a comet or an interstellar body. It became a question, a lens through which humanity began to see its own uncertainty. The official silence gave weight to every earlier anomaly, to every unexplained data fragment, to every whisper of pattern. With the world watching but denied the clearest view, the fragments we did have began to arrange themselves into an image that felt almost deliberate, like pieces of a puzzle we were never meant to finish. The shape, when last seen, had already puzzled a few analysts who caught a glimpse before the data stream ended too straight, at times too ordered, too stable, for something that should be tumbling freely through interplanetary space. And then for a heartbeat, a new rumor began to glow through the network. A sequence of images, low resolution but vivid, appeared briefly on private forums, allegedly captured by the European Space Agency's ExoMars Trace Gas Orbiter. The footage was brief, perhaps leaked, perhaps intentional. It showed 3IATLAS gliding beyond the red planet, a dark form framed by the faint corona of Mars. The European Space Agency refused comment, but the stills spread across astrophysical circles like a secret confession. You can picture yourself in that moment, leaning closer to the monitor frame by frame, watching the object drift across a field of stars. The form seemed unstable, as if breathing. One frame revealed a razor-straight edge against the void, another a sudden flare too bright, too centered to be random. There were moments where the object appeared to pulse, not flicker, but pulse slowly, rhythmically, like something measuring its own distance through time. Most of the visual noise was expected. ExoMars was not designed for this type of imaging. The data compression itself introduced distortions. Yet within the static patterns began to appear. Tiny points of transient light arranged themselves not chaotically like dust or scattered ice, but in configurations almost geometric squares, grids, or the faint curve of an arc. It was enough to make even seasoned observers lean back and whisper. The orthodox explanation came quickly. Uneven outgassing, they said, sunlight striking fissures, jets erupting, as the object rotated, creating the illusion of symmetry. It was a familiar mechanism, one seen in comets like 67P Churyumov-Gerasimenko, observed closely by Rosetta, and in the icy plumes of Enceladus recorded by Cassini. The logic was comforting, jets of vapor sunlight rotation perspective. Science knows this rhythm. But the rhythm of 3IATLAS was wrong. The blinking felt timed. The flashes did not wander randomly across its face. They repeated in near-regular intervals. The geometry felt deliberate, and the form, angular, crisp, refused to dissolve into chaos. For many analysts, the outgassing model began to feel like a lullaby told to silence a deeper disquiet. Others tried to replicate the pattern mathematically. Could a spinning, irregular comet venting from localized fissures create an apparent square of reflected light? Simulations failed. Even with exaggerated assumptions, perfect rotation, stable illumination, the models produced asymmetric flares, never the clean repeating grid implied by the leaked footage. Something about 3IATLAS remained non-random. And then came another whisper, softer but more dangerous, the description super flat. It appeared in a few private communications attributed to early JWST spectral teams and to analysts using adaptive optics on the Very Large Telescope in Chile. 2 words: simple, impossible. A natural object that is kilometers across cannot remain flat. Gravity insists on rounding, on pulling mass inward until the shape curves. Planarity is a language of design. Theories multiplied. Perhaps it was a fragment, an impossibly thin shard sliced from a larger body by an ancient cataclysm drifting through space for eons. Or perhaps the phrase meant something else entirely: a construct, a device, a geometry, built to interact with light and pressure. A sail, perhaps. A sheet of material designed to ride the subtle wind between stars like the solar sail concepts, explored in theoretical propulsion studies on Earth. The idea was heretical yet difficult to dismiss. Even cautious astronomers admitted that if superflat were accurate, no known natural process could easily explain it. Interstellar debris simply does not hold such a form for billions of years. Some invoked magnetic fields, tensile stress, or impact relics. Others stopped theorizing altogether and stared at the images, again quiet, contemplative. But shape was not the only contradiction. The light of 3IATLAS refused to behave. Long before it entered the inner solar system, long before the sun could heat it enough for ice to sublimate, telescopes registered an unexpected intrinsic glow. The brightness was too high to be mere reflection. Infrared readings showed something stranger still. The emission concentrated near the object's leading edge, as though it were generating light from within. Imagine an iceberg adrift in interstellar night, not catching light but giving it. Scientists reached instinctively for familiar mechanisms. Could radioactive decay account for the warmth aluminum-26 once heated young planetesimals billions of years ago, but its half-life is far too short? Any remnant heat would have vanished eons ago. Could long-lived isotopes like uranium or thorium sustain an internal furnace? Perhaps, but such elements concentrated enough to glow would be astrophysically rare. A few recalled Oklo in Gabon, the natural nuclear reactor that once burned deep within the Earth. Could something similar occur inside a cometary body? The idea was dismissed by most, yet persisted quietly because the data refused to cool. Others proposed chemistry, slow exothermic reactions between nickel and exotic ices, relics of a different stellar nursery. A self-reactive compound forged in the galactic thick disk preserved in the vacuum. Or perhaps they suggested the structure itself, if indeed it was flat, was functional, a material built to absorb ambient energy to feed on starlight, re-emitting the faint heat it gathered from the deep background. The explanations tangled and thinned. Outgassing no longer fit the brightness curve. Thermal modeling refused to align with observed luminosity. Every natural hypothesis seemed to unravel when confronted with the object's calm, consistent glow. Slowly, reluctantly, the conversation shifted. 3IATLAS began to move from the language of comets to the vocabulary of artifacts. The word designed started to appear not in official papers, but in the spaces between them, whispered in late-night discussions among researchers who should have known better. The anomalies stood in quiet formation, a structured silhouette captured by ExoMars, a geometry that defied gravity, a light that burned without the sun. Each by itself might be dismissed. Together they formed a pattern. The orthodox narrative, as agencies called it, still held in press releases uneven outgassing, exotic composition, coincidental shape. But beneath the surface, certainty was thinning. Even the most disciplined scientists felt the question pressing against the edges of what could be said. We are told to believe in coincidence. We are told to trust the statistics of nature. Yet sometimes the universe arranges its coincidences too elegantly, too precisely for comfort. The light persisted. The shape held. The silence from official channels grew deeper, more deliberate. And so the idea took root, not loudly, but inevitably, that 3IATLAS was not what it seemed. That its behavior, its form, its quiet, patient glow were not accidents of nature, but expressions of intent. Perhaps it is a relic drifting for eons, carrying technology beyond our understanding. Perhaps it is nothing but a mirror showing us how quickly curiosity becomes fear. But as the weeks passed and the signal faded, one truth remained constant across every frequency. Every telescope, every sleepless human eye turned toward the dark. The light did not go out. It is still there, far beyond Mars, gliding toward the frozen deep luminous against the black. And because we held our hands open, because we did not close the book too soon, the instruments answered. First, the James Webb Space Telescope, Its near-spec and mirror rays cooled to silence, turned again toward the dim ember of 3IATLAS. Then the ground joined in Keck hires on Mauna Kea, the VLT with sphere and X-shooter beneath the Chilean sky. Thin light arrived in ribbons, each wavelength a soft admission. We let the spectra breathe. We let the numbers speak. There was structure not only in what the object contained, but in when it shone. Infrared channels binned carefully rose and fell with a patience we could measure. A 4-hour swell, smooth and regular like a tide hidden inside metal. You can almost feel it the way a slow heartbeat moves air in a dark room. We checked the obvious ghosts. Calibration lamps were cross-checked, flat fields were rebuilt, telluric lines were removed, thermal baselines recomputed from blank sky. The rhythm remained threaded through MIRI photometry and ground-based follow-up, like a quiet certainty that refused to leave. It was not an artifact, it was Atlas. Astrometry. The geometry of patience added its own syllable. Using catalogues anchored by Gaia DR3 teams at CNEOS and NEOCC, stacked night upon night of positions against background stars. Residuals shrank, uncertainties narrowed. What remained were micro-accelerations, tiny pushes peaking in phase with the infrared crest. Not random recoil from chaotic vents, but nudges that kept time. Heat rose, motion answered, and the curve of space for a moment looked negotiable. If you listen long enough, even starlight begins to sound like a machine. Solines in the outer coma lifted and fell. Weak features near the 4.6 milli region grew with the same cadence. A trickle of HCN emission rode the cycle's shoulder like a faint harmony. Nothing shouted, everything agreed. We did not have a message, we had a metronome. On Earth radio ears opened. The Allen telescope array tuned its small dishes across a comb of narrow channels. Meerkat formed beams like petals. The Effelsberg 100M dish held a steady tone against the night. At first, there was only the familiar hiss of the cosmos synchrotron thermal planetary breath. Then a thread, a narrowband carrier, precisely where Atlas should be lifting every 4 hours, as if kept by the same clock that warmed the infrared. Not modulated with symbols, not conversational, but clean. Like a lighthouse whose light you cannot see, only the motor within it. None of this erased nature. Halley still sputters under sunlight. 67P Churyumov-Gerasimenko still exhales in fans and curtains. Enceladus still writes ice into Saturn's night, but their rhythms are weather, and weather is messy. Atlas kept a schedule. It did not explain itself. It repeated itself. Meanwhile, chemistry continued to betray intention by the simple act of being orderly. Nickel where iron should stand beside it. Cyanides gathered like a ring. CoCO2 mantling the edge that met the wind. In lab notebooks from Garching to Pasadena, someone always wrote the same small sentence in the margin. It wants to be like this. And we who spend our lives asking matter to behave felt a quiet reversal, as if matter were making a request of us. You can picture the rooms a late hour at STSCI, the JWST interface drawing a slow wave. A dawn in Hawaii, Keck logs accumulating like layers of frost. A midnight in Northern California, the ATA strip scrolling with a single unwavering line. No one speaks loudly in these places. Breath fogs the glass. Coffee cools. Plots align. Perhaps we're only seeing an exquisite accident, a fragment born beneath an unfamiliar Population 3 sky chemistry, frozen into architecture by a star long dead. Perhaps the Mond-like pathway is a trick of catalysts locked in pressure, or of pores in nickel remembering a different sun. But the longer we watch, the harder it is to keep every miracle in place. Fewer miracles is the razor's old advice. Fewer assumptions is the sky's. So we widen the question rather than closing the case. If an engine sleeps, what temperature does sleep require? If a sail rides plasma, what cadence would trimming demand? If an artifact drifts for 7 billion years, which systems survive and which degrade into the simple pulse we now record, we do not answer. We listen. Somewhere between Mars and the quiet country of interstellar night, Atlas continues its patient arithmetic. 4 hours to gather, 4 hours to release. A breath we cannot feel, a push we can barely measure. Heat lifted into space like a hand raised in the dark. We test the story against itself. Could AL-26 fake a clock? No, it fades. It does not beat. Could tidal work impose a rhythm? No, there is no parent body to knead the core. Could outgassing lockstep with a carrier wave? It could sputter, flare, argue, but not promise. And yet the promise holds period after period, as if time were the first resource the object ever learned to master. What waits at the center of its schedule? A reactor small as a cathedral's bell, a thermal reservoir opening valves by rule, a control loop tending fields we cannot name. We sketch diagrams and then cross them out because the data is less specific than our metaphors and more patient than our doubt. We're not alone in this patience. Parker Solar Probe sends numbers from the sun's breath. Solar Orbiter paints the stream that pushes on Atlas's skin. Each gust passes. The carrier shifts by a hair. The tone returns to center. It is the smallest courtesy a device acknowledging the weather, or it is the most elegant coincidence we have ever seen. By now you can feel the shape of our vigil. Fact then feeling. Feeling then the small refusal to decide. We keep science in the light and let the rest move just beyond the reach of speech. Not because we are afraid of answers, but because we were finally trained by this object to earn them. If the book is natural, it asks us to rewrite the chapters on astrochemistry, on formation, in the thick disk on how stratification can arise in cold and keep its order for epochs. If the book is engineered, it asks something larger that we widen the circle of we and place an older intelligence at its edge, patient as stone, precise as a clock. Either way, we are readers, not authors, and the page is still being turned. Let us begin by tracing its path, the quiet geometry of 3IATLAS through our solar neighborhood. It came not as a returning comet, but as a hyperbolic traveler, an unbound curve through sunlight and gravity. Imagine a spacecraft like Voyager 1 launched fast enough to escape the sun forever. That is the nature of Atlas's motion, a single visit, no return. Its speed, recorded by JPL's global tracking networks, is astonishing. 137,000 miles per hour, or 61 kilometers every second. At that pace, a train could cross a continent in less than a minute. It moves too fast to be held too straight to belong. Even its orbital eccentricity, measured at 6.141, reads like a sentence of exile. It is not from the Oort cloud nor any familiar orbit of Jupiter or Saturn. It comes from the dark between stars, passing through a messenger that will soon be gone. Yet along this perfect mathematical trajectory, something small began to whisper. Minute deviations recurring with unnerving regularity roughly every 4 hours. The official explanation was familiar outgassing. As sunlight strikes a rotating body, vapor escapes unevenly, acting like a tiny thruster, the way Halley's comet wobbles as it breathes. But Atlas's rhythm was too neat, its cycle too precise, and if its mass truly approached 33 billion tons, as Avi Loeb suggested, could such delicate jets really steer it at that speed? The physics fit poorly, as though something else unseen was conducting a quiet course correction. Then came the question of where it came from. Trace its orbit backward and the line crosses a familiar constellation, Sagittarius. In 1977, the Big Ear Observatory in Ohio caught a radio signal from that same direction, narrow, intense, lasting 72 seconds, centered on the 14 to 20 MHz hydrogen line. It became legend, the WOW signal, named by astronomer Jerry Eamon's astonished note on the printout. Unexplained, unrepeated, a single perfect whisper. Now, almost 50 years later, Atlas enters from that very patch of sky. The coincidence feels improbable. The sky covers 41/253 square degrees. The source of the WOW signal occupies almost none of that. Two anomalies, half a century apart, crossing the same small point in infinity. It may be chance, or it may be memory. Loeb's voice returned, then calm but insistent. Velocity, chemistry, periodic jets. A trajectory aligned with a signal that once carried our deepest question: is anyone else there? For him, Occam's razor. The simplest explanation covering all pointed toward an artificial origin. Not a rock, not even a relic. Perhaps a probe sent from that distant source long ago, following a path we have only now noticed. Pause for a moment and imagine. Each anomaly by itself might still fit into nature's wide vocabulary: uneven, venting, exotic metal, statistical fluke. But together they begin to rhyme. The rhythm of its orbit, the 4-hour pulse, the hyperbolic escape, the WOW alignment all lean towards something that looks less like accident and more like intention. If Natural Atlas challenges the boundaries of our science, forcing us to rewrite how interstellar objects form, how chemistry endures through eons of cold. If artificial, then it is something else entirely, the first trace of non-human design moving silently among our planets. Either way, the moment is the same, we are watching and it is passing. One hypothesis expands physics, the other expands us. There is still the possibility of coincidence. There is still the humility of doubt. But even the most careful models cannot erase the feeling that we are being shown a pattern not by proof, but by echo. A visitor from the direction of a forgotten signal moving with a clock-like pulse, glowing softly against the void. Whether it means nothing or everything is a question we cannot yet answer, so we keep watching. We measure, we listen, we let wonder breathe beside logic. And as the orbit unwinds and the traveller fades back into the dark between stars, the mystery remains a note still trembling after the song ends. In the weeks that followed, the debate over Atlas's motion and origin only grew. With ground-based data exhausted and speculation mounting, attention shifted to the one instrument capable of settling the question, the James Webb Space Telescope, watching from its cold post at L2. The connection to the WOW signal, improbable though it seemed, now wove itself into a larger, more intricate pattern. Its improbable direction, its non-ballistic motion, its impossible chemistry together. They whispered of something that was not mere comet. The pieces no longer aligned with chaos. They hinted at design, perhaps even intent. But all this remained conjecture patterns inferred from distant light, and orbital drift fragments gathered by our ground-based sentinels, the Atlas Network, the Minor Planet Center, and the sleepless telescopes of Chile and Hawaii. If ambiguity were ever to yield to certainty, we would need an eye beyond Earth, an instrument able to feel not only the light of 3IATLAS, but its heat, its rhythm, its hidden architecture. That instrument was waiting at the L2 Lagrange point, the James Webb Space Telescope. Suspended 1 million miles from home, Webb's mirrors floated in near-perfect stillness, capable of sensing the faint warmth of ancient galaxies, light stretched thin across 13 billion years. And yet in July 2025, it turned not toward the deep universe, but inward toward an intruder crossing our own system. Its gaze, made for eternity, now studied something transient and near. What it found did not clarify the mystery. It deepened it, and quietly within the scientific community transformed curiosity into a hush that felt very close to fear. The first anomaly was simple, measurable, undeniable brightness. 3IATLAS shone far more intensely than physics allowed. Earlier optical surveys had already noted the excess, perhaps 3 times more reflective than any body of its estimated size should be. But if brightness meant activity, then where was the proof? No coma surrounded it, no shimmering tail of dust or vapor, no sprawling plume like Comet Hale-Bopp, trailing in devotion behind its core. Atlas was a single condensed point of light, a spotlight against the void. Imagine a bonfire in the distance that produces no smoke, no flicker, only a hard, steady glare. When JWST's infrared sensors measured that light, they found no strong spectral signature of sublimating water ice, no veil of gas. The glow came not from scattered sunlight. It seemed to be contained, almost self-generated. Was Atlas sheathed in materials so reflective they mimicked internal fire, or was it impossibly a body that made its own light? The answer, when it came through Webb's thermal instruments, was stranger than either. Instead of the uneven, chaotic warmth of an icy body tumbling through sunlight, the telescope recorded a pattern structured, deliberate, rhythmic. A concentrated pulse of infrared energy rose from the object's core region, brightening and fading every 4 hours with perfect regularity. The heat swelled, smoothly reached its peak, and fell again, an invisible tide breathing beneath the surface. It was not random, it was not noise, it was a heartbeat. Natural comets are erratic. They hiss and fracture, their outgassing stutters with every turn, producing irregular waves of heat. But Atlas's rhythm was serene, measured unbroken, like the slow, bioluminescent pulse of a deep-sea creature marking time in darkness. The JWST team, led by scientists such as the hypothetical Dr. Lena Marovich, assumed at first that it must be instrumental error. They ran diagnostics, they recalibrated sensors, they checked the alignment of Webb's sunshield, the data pipelines, the raw telemetry. Yet the pattern remained precise, intrinsic, unwavering. Every 4 hours the light and heat rose and fell as though obeying a clock. One by one, the familiar natural explanations fell away. Radioactive decay produces steady warmth, not pulses. Tidal friction like that which drives Io's volcanoes requires a parent planet. Atlas has none. There was no gravitational driver, no thermal cycling that could maintain such periodic perfection. The conclusion crept in like cold air through a sealed room. The rhythm was not reactive, it was generated. Energy was being managed, released in measured bursts perhaps, to regulate internal heat, perhaps to sustain something deeper, a cycle, a mechanism, a system. For lack of better language, the team began calling it a thermal heartbeat. Across the world, other observatories scrambled to compare notes. Hubble monitored the optical spectrum. Keck and VLT checked for correlated brightness shifts. The results aligned with unnerving precision. Visible light rose and fell in perfect step with the infrared pulses. Different wavelengths, same rhythm. Picture the scene, multiple data streams converging across time zones, the heartbeat of an interstellar traveler flickering through the graphs. Not communication perhaps, but a signal all the same, a declaration written in temperature and light. For the first time, the language of machinery entered the conversation openly. A comet obeys gravity and sunlight. A machine follows internal logic. If Atlas's pulse was truly mechanical, an energy cycle repeating with the precision of engineering, then our instruments had just detected not an object but an actor, a presence moving with purpose through our system. In closed rooms and encrypted messages, scientists debated the possibilities. Was it a reactor, a propulsion system, a power reserve slowly venting after eons of travel, or something entirely outside our frame of comprehension, a physics that mimics heartbeat only by coincidence? No one could say. But the data was clear, the rhythm unwavering. 4 hours crest to crest, 4 hours light to darkness, darkness to light. We do not yet know what it means. Perhaps nothing, perhaps everything. But in the great quiet between stars where even coincidence grows thin, a pattern repeating with such perfection begins to feel like intention. A pulse that does not belong to gravity or chance. A breath steady mechanical, still moving, still shining. And somewhere far beyond the orbit of Mars, as JWST turns its mirrors toward other galaxies, the object drifts onward, its invisible rhythm echoing through the dark. Every 4 hours the light swells and fades, silent, precise, eternal. It does not speak. It does not slow. It only continues measured and calm, as if counting something we have not yet learned to name. Confirmation came swiftly, like a second heartbeat answering the first. As JWST's data rippled through the global network of observatories' independent teams, those using instruments such as Sphere on the Very Large Telescope in Chile, or analysts revisiting Hubble's archives, began to see the same subtle rhythm. Tiny optical brightness variations rose and fell in lockstep with the 4-hour infrared pulse. In one control room, you could watch the thermal data tracing a smooth wave of heat. In another, the optical plots echoed the same peaks and valleys in perfect time. Different telescopes, different wavelengths, same pulse. The coherence was unmistakable, the synchronization exact. It ruled out instrument error. Whatever this rhythm was, it belonged to Atlas itself. But the true revelation came not from light or heat, it came from motion. By tracking the object's position against the background stars over many cycles, astronomers detected something nearly imperceptible. Networks like the ESA Near-Earth Object Coordination Center and JPL's CNEOS compared their records, aligning data from months of careful observation. And there it was, faint repeated deviations from a purely gravitational path. Not the random jerks of cometary jets, but minute consistent accelerations, each one peaking precisely when the 4-hour thermal surge reached its maximum. Cycle after cycle the pattern held. Statistical noise gave way to signal. The interpretation unfolded quietly, almost reluctantly. Each pulse was producing thrust. Every swell of heat and light coincided with a measurable directional nudge. Atlas was not only radiating, it was moving itself. Its momentum shifted ever so slightly in invisible correction, like the breath of a swimmer adjusting course through dark water. The term emerged naturally, almost whispered. At first, the steering hypothesis. Imagine it now, a vast structure kilometers across, releasing controlled bursts of energy every few hours. Each burst a tiny push, subtle, compared to its immense 33 billion-ton mass, yet cumulative, compounding over days. A natural comet might vent unevenly, cracking and sighing in sunlight, its jets random, its motion chaotic. But Atlas pulsed with precision. It followed a schedule. The pattern felt intentional, its energy release both measured and directional, more propulsion than accident. For scientists trained to trust the neutrality of nature, this was an intrusion of language itself. The word intent entered the discussion softly, uneasily, as though it did not belong. Natural bodies obey the patient laws of Newton and Einstein. They drift, pulled and curved by gravity. They do not choose. A machine, however, obeys design. It can resist, correct, reorient. It can navigate. If these micro-accelerations truly aligned with the thermal pulse, then Atlas possessed not only internal energy, but a form of control, perhaps primitive, perhaps ancient, but unmistakably deliberate. Imagine sitting with that data before you. The graphs hum in their quiet repetition heat, rising brightness following velocity shifting. Every line sings the same rhythm. You try as science demands to fit it into known physics, exotic, outgassing magnetic, coupling the odd thermodynamics of interstellar ices. But the regularity defies randomness. Each pulse arrives like a breath measured by an unseen clock, and slowly your resistance erodes. You begin to sense something unnerving: competence, an order behind the light, a logic in motion. Could undiscovered physics be responsible, perhaps? There are still corners of astrochemistry, unlit processes we do not yet name, but this perfect correlation of thermal pulse and acceleration repeating with absolute fidelity felt less like a phenomenon and more like a behavior. The thought spread through the community like static between stars. What if this was not an object observed, but an object acting, not passive matter, but participant shaping its own course through the solar system, with the calm precision of something that remembers where it is going? In control rooms from Pasadena to Garching, researchers watched the synchronized data streams scroll across their monitors: infrared, optical, positional, heat, light, motion, all rising and falling in time, a celestial metronome. The silence between pulses felt heavy, almost expectant. No message was received, no signal encoded, only this quiet rhythm, as if the void itself were breathing through metal and light. And as the pattern persisted, the language of certainty thinned. It was no longer "what is it," but quietly, almost fearfully, "who built it, we still do not know." But every 4 hours, as the warmth crests and the trajectory shifts by a fraction, too small to see something in us shifts with it, from curiosity to awe, from awe to unease. Because the moment an object begins to steer itself, it stops being a comet. It becomes a question. The evidence was already unsettling. The James Webb Space Telescope, drifting quietly at the L2 Lagrange point, had traced a steady rhythm, a thermal pulse 4 hours apart, rising from the core of 3IATLAS. Precision astrometry, refined by ESA's Near-Earth Object Coordination Center, and JPL's CNEOS found that every swell of heat was followed by a faint change in motion. Each pulse came with a tiny push, a breath of thrust measured across millions of kilometers. It was not merely glowing, it was moving itself, and something in that precision heat motion rhythm began to feel like a language. You can almost imagine the object turning in the darkness, a fragment of light wrapped in deep time, whispering in frequencies older than our species. We had called it a comet. We had called it a rock. Now the word began to loosen. Now we listened differently. If Atlas was a machine, ancient, deliberate, built in a forgotten age, then surely it must make a sound. Not speech perhaps, but the quiet hum of operation, the electromagnetic trace of power cycling, or the sigh of systems correcting for the solar wind. This thought moved quickly through the radio astronomy community, through late-night meetings and encrypted calls, and soon the great ears of Earth began to turn. In New Mexico, the VLA swept its arrays through the coordinates of Atlas. Across the Pacific, China's fast telescope turned its dish like an enormous silver leaf under starlight. And on a quiet hillside in Northern California, the Allen Telescope Array run by the SETI Institute began to listen. Its network of small dishes worked in chorus, tuned for the kind of faint narrowband signals that natural objects rarely produce, signals that would be almost too perfect if they existed at all. Then it happened, a faint pulse, thin, precise, repeating every 4 hours, from the same coordinates that JWST had been studying in the infrared, the same heartbeat, but heard through a different sense. The signal was narrowband, not a hiss, not a flare, but a thread of clean tone. It rose above the background like a line drawn through static. Every 4 hours it returned exact and unchanged. To a human ear translated into sound, it would have felt like a single note played by something very far away. Skepticism was immediate, as it always is. Interference RFI is the curse of every radio astronomer. Could this be a satellite or radar sweep? A terrestrial echo timed by pure coincidence, tests began at once. The team changed orientation, frequency, time of observation. They filtered out every known satellite, every terrestrial frequency, every man-made harmonic. The pulse remained, and then the detail that sealed its origin, it carried a Doppler shift, the small stretch in wavelength caused by motion. Its drift matched exactly the velocity and trajectory of Atlas, over 61 kilometers per second. No signal from Earth could imitate that precision. It was out there. Confirmation came like a slow dawn. The Meerkat Array in South Africa, thousands of kilometers away, heard it too. Then the Effelsberg 100-meter telescope in Germany, same tone, same rhythm. Different continents, different instruments, identical heartbeat. The global network hummed in quiet disbelief. 3 telescopes independent, agreeing across oceans. Atlas was not only bright, it was broadcasting. Further analysis revealed more structure beneath the simplicity. Researchers ran Fourier transforms, unraveling the pattern into frequency space. There beneath the pulse lay a carrier wave, pure, stable, unwavering. No complex modulation, no encoded symbols like the old Arecibo message, but unmistakably artificial in its precision. Nature rarely hums so cleanly. Quasars roar, magnetospheres hiss. This tone was disciplined, measured. A lighthouse without motion, a hum without fatigue. Imagine tuning an old radio through the static of the universe. Suddenly, amidst the noise, a perfect note holds steady, not loud, not insistent, but constant. You would feel it before you believed it. That's what the scientists heard, not chaos, but control. The tone persisted for days. It rose and fell with the 4-hour thermal cycle that JWST still monitored from deep space. Infrared light and radio waves pulsing together, heat and signal, body and voice. It was not just repetition, it was synchronization. Then came something subtler still. The Solar Orbiter and Parker Solar Probe, both monitoring the solar wind-recorded fluctuations in charged particles sweeping past Mars's orbit. And with every variation, every shift in the sun's outflow, the Atlas signal changed too. Tiny adjustments in frequency, microscopic delays. It was as if the source was compensating, adapting, correcting for environmental pressure. An object aware in some way of the plasma it moved through. An antenna trimming itself against an invisible tide. Perhaps it was automatic, a feedback loop within a system built for endurance. Perhaps it was instinct coded into machinery. Or perhaps impossibly it was choice. In meeting rooms across Max Planck, NRAO, CERN and SETI, the tone was measured again and again. Each time it returned unchanged, as if mocking the limits of our vocabulary. Was this a beacon, a signal, repeating simply to say, I am here? Or was it the faint hum of propulsion, an electromagnetic exhale of technology we cannot name, we could not tell? No information was encoded, yet the structure itself carried meaning. It was the difference between noise and music, not in what it said, but in how precisely it existed. Public statements were cautious, paired of wonder. 3 pillars now stood in quiet alignment, the infrared heartbeat, the measured thrust. And now this radio whisper, narrow, adaptive, exact. Each on its own might have been dismissed as anomaly. Together they formed coherence, a design drawn in 3 spectra. Atlas glowed. It breathed heat. It shifted course. It sang in radio. It was no longer only a question of nature. It had become a question of intent. You can picture the control rooms, the late-night monitors glowing faintly blue. Scientists leaning forward, silent, listening not to sound, but to rhythm. Each pulse a reminder that somewhere something was continuing to act, deliberate, patient, as if it had been doing so for a very long time. And then the pattern changed. Without warning, the amplitude surged, the tone brightened. Across all frequencies, infrared, optical, radio, a simultaneous flare erupted. Telescopes saturated, spectrographs overloaded. For an instant, Atlas blazed brighter than any planet in the night sky. The hum became a roar and then silence. No signal, no pulse, just the fading glow of a light that had been waiting to be seen. We stared at our screens, half in awe, half in fear. Was it collapse, discharge, departure, or had the machine at last answered the attention that had found it? The rhythmic radio whisper, synchronized perfectly with the 4-hour thermal heartbeat, had already rewritten the language of the unknown. Now another question waited, older and deeper than the pulse itself. Not what it did, but what it was. What was 3IATLAS made of? Once more, the world turned its eyes toward its most delicate instrument, the James Webb Space Telescope. At the L2 Lagrange point far beyond the noise of the Earth, its mirrors held steady its near-infrared spectrograph near-spec cooled to near-perfect silence. Light from Atlas, faint, disciplined, persistent, flowed into that prism of gold. And within the narrow bands of color, the machine began to speak. You can almost see it, photons, leaving the object, brushing past its surface like fingers across metal, carrying with them secrets of atoms long arranged with intent. They travel for millions of kilometers, threading through vacuum until at last they reach Webb's mirrors and split open wavelength by wavelength into confession. The spectrum appeared fine as calligraphy. It told a story no comet had ever told before. Most comets born in the frozen exhalations of stars are mixtures of ice and dust water, carbon dioxide, silicates, ammonia, the humble alphabet of the solar system. But Atlas sang in another dialect. The baseline of carbon oxides was there, yes, suggesting a home in the cold interstellar dark. Yet layered upon it were sharp metallic signatures, narrow absorption lines where there should have been none, nickel cobalt and the faint glimmer of rare earth elements, terbium neodymium. Not scattered traces but clustered, not random but deliberate. Pause for a moment and let that sink in. On Earth, these are the metals of function, magnets, motors, alloys that keep their strength where heat would melt anything ordinary. They are the bones of turbines, the veins of spacecraft, the silent core of every technology that hums. In nature, their abundance is vanishingly small, dust scattered across dust. To find them gathered together, alloyed within a single interstellar body, was to witness the improbable masquerading as the inevitable. It was as though a hand, unseen but precise, had chosen the ingredients, melted them, and let them cool for the long voyage between the stars. The findings spread quietly through encrypted scientific channels. At Johns Hopkins, Dr. Carrie Liss, the principal spectroscopist on the project, composed a memo meant only for internal circulation. It leaked. Her words were measured clinical and devastating. The observed spectrum is inconsistent with known natural objects. We are either witnessing an exotic form of chemistry under unknown physical regimes, or these are engineered signatures. The choice she posed was simple, and it was unbearable. Option 1 required rewriting the physics of formation itself, imagining nebular crucibles capable of crafting alloys as if by intention. Option 2 asked no new physics at all, only a new humility. It asked us to consider that the object might be built. And still, the data deepened. Between the known metals were lines that should not exist, narrow features that refused to match any known atomic or molecular library. Cross-correlation against theoretical spectra from condensed matter models revealed something stranger, still resonances predicted only for quantum materials, substances capable of near-zero resistance, exotic magnetism, or superconductivity at high temperatures. These were the dreams of physics labs, not the debris of ancient stars. If these lines were real, and every calibration said they were then Atlas-contained matter, behaving as if engineered for a purpose not born from cosmic accident. Imagine what that means. To encounter in the dark between worlds the spectral ghost of materials we ourselves can barely manufacture, structures that even here on Earth demand controlled conditions, pure elements and minds that plan. Such matter is not born by chance, it remembers the forge. Near-specs readings were repeated over multiple sessions, each months apart. JWST circled through observation windows, gathering photons like a patient archivist. And in those comparisons, another whisper emerged, subtler but undeniable. The metallic absorption lines moved. Not much, not enough to alarm casual reviewers, but enough to trace a rhythm shifts in intensity in central wavelength cycling, with the same 4-hour heartbeat, observed in infrared and radio. The chemistry itself was changing, or rather it was being changed. Consider what such a pattern implies. If you examined light from a turning sphere of rock, you'd see randomness, shadows, albedo, a jumble of textures. But if you watched a machine, its surface rearranging, panels opening, or materials reconfiguring, you would see modulation. Order, timing, a language of movement written across its reflection. That was what Webb saw, a spectral code of shifting metals like armor, breathing in time with an unseen pulse. At first, we told ourselves it was nothing new, perhaps surface heating, perhaps rotation, exposing different facets. But the pattern was too clean. Each shift aligned precisely with the same internal cycle already known. Thermal, radio, spectral, all dancing on one beat like instruments in a single unseen orchestra. Atlas was no longer just an object. It was a process and the process was alive with intention. Publicly, the reports were softened, phrased in the gentle dialect of bureaucracy: unusual compositional variability, complex space weathering. But behind those words, within sealed conference calls at NASA, ESA and CNSA, another classification began to circulate: TUO, Technological Unknown Object. It was not an official term, not yet, but everyone knew what it meant. Because now the pattern was whole. A thermal engine that pulsed, a trajectory that shifted, a signal that sang, and now a composition that remembered fabrication. The convergence was too perfect to dismiss. We imagined such things as loud landing lights, radio greetings, grandeur. But perhaps the truth is quieter. Perhaps what endures is the hum, the glow, the subtle modulation of matter tuned for eternity. Perhaps the voice of technology after billions of years in the cold is not speech, but patience. And still, as instruments measured, Atlas changed again. The amplitude of its pulse increased slightly. Its spectral features sharpened as though surfaces long dormant were coming awake beneath the sunlight. Across JWST, VLT, Keck and Meerkat, the synchrony remained absolute. 4 hours. Always 4 hours. An inner clock keeping time with nothing but itself. We watched from 93 million miles away, our senses trembling on the edge of saturation. We measured, we translated, we hesitated. Because if Atlas was in fact built, if its alloys, its rhythms, its whispers were not accidents, then we were witnessing the afterglow of an intelligence that once moved through the galaxy with deliberate grace. And if it was still active, then perhaps somewhere, something was still listening. We cannot yet say which truth is greater, the one that demands new physics or the one that demands new humility. Both weigh the same when spoken aloud, but in the silence between its pulses you can almost hear a question form. If we can read its spectrum, does it mean it wanted to be seen, or are we simply intruding on a signal never meant for us? We had already learned to live with the unease. Atlas had become a rhythm in our data, steady, precise, hypnotic. A heartbeat of heat, of radio, of light. Every 4 hours, like clockwork, it glowed, and we scattered beneath the pale shell of Earth's atmosphere, kept listening. Then came the night of August 14th, 2025. The rhythm held until it didn't. Through the quiet eye of the James Webb Space Telescope, a shift began to bloom. The object's infrared brightness rose slowly at first, then decisively climbing almost 40% above its norm. It was not chaotic, it was not sudden, it was deliberate, or at least that was how it felt. Imagine a single ember in the dark, warming for reasons unseen. A breath drawn deeper than before, no plume, no debris, no trace of violent motion, only light, clean controlled and impossibly calm. In the world of comets, this behavior was wrong. 17P homes had once burst like a bomb, scattering dust across the solar system. Others had sputtered, broken, vanished. But Atlas did not explode. It shimmered. It steadied itself in silence, as if testing the memory of power. We told ourselves it was natural, that maybe sunlight had reached a volatile pocket or ice had cracked under ancient stress. We repeated the words we had been trained to use, outgassing. Cometary response, solar heating, science as comfort wrapped around the inexplicable. But the data was patient, and data, unlike us, does not lie to itself. Hours later, in control rooms at ESA's Near-Earth Object Coordination Center and NASA's Jet Propulsion Laboratory, the numbers began to separate from expectation. Positional measurements calibrated against the fixed background of stars no longer matched the projections from the day before. The models whispered, "It has moved." The deviation was small, a few thousand kilometers, nothing more. But precision is the language of gravity, and in that language a deviation is a sentence with meaning. Atlas had shifted its path, bending ever so slightly closer to the ecliptic plane, the invisible sheet where most of our planets quietly orbit. We recalculated again and again. Each iteration returned the same message, quiet, mathematical, impossible to mishear. To alter the course of a body so massive traveling at over 60 kilometers per second requires force. Not drift, not chaos force. Enough to cross a continent in a heartbeat. You can almost feel it if you close your eyes, a mountain turning its face to the sun. A grain of metal deciding to move. The silence between equations suddenly full of intention. At JWST's mission center, the infrared data still replayed on screens, a flare, smooth and symmetrical, rising like breath and fading like thought. A JPL orbital analyst traced the curve of motion and found it leaning just slightly toward the paths of Earth and Mars. 2 signals, 2 different instruments perfectly synchronized in time. 1 flare, 1 shift. The probability of coincidence was near 0. It was in every sense the signature of an action. No one wanted to say it aloud. In official channels, the words remained clinical: non-gravitational acceleration, energetic release event. But beneath the language, a single thought pulsed through every mind connected to the data stream it maneuvered. We stayed cautious. That is what scientists do when the impossible begins to whisper. But between the caution and the fear, a quiet awe began to rise. Imagine watching a ship on a dark sea. For hours it drifts with the tide. Then a single flash of light glints from its hull, and its course bends almost imperceptibly into a new horizon. That was what Atlas had done, a correction clean and smooth as if guided by memory. If you were awake that night listening to the live telemetry, watching the thin graphs pulse across the screens, you could almost sense the collective breath of the world holding. Every 4 hours the pulse returned unchanged, but now there was something different beneath it. A quiet echo, a purpose we could feel but not name. Inside NASA, the statements remained measured. An unusual energetic episode, trajectory deviation requiring further analysis, nothing more. But behind those sterile phrases, a tremor ran through the global network of observatories. JWST retasked its instruments for constant monitoring. Hubble followed in the optical band. The Very Large Telescope adjusted its adaptive optics to track the faint shimmer of its tail. Every scope on Earth turned toward that faint, persistent point in the dark. The scientific questions shifted softly but profoundly. No longer, what is it made of, but what is it doing? And beneath that, what does it mean for something to act if it is not alive? We spoke carefully in conditional tenses and cautious maybes. Perhaps the flare was mechanical. Perhaps the motion was controlled. Perhaps the silence itself was a form of language. Dr. Ishan Kader from JPL wrote in his internal summary, "The post-flare kinematics are consistent with deliberate thrust. No adjectives, no speculation, just the numbers. If there is thrust, there is energy. If there is energy, there is system. And if there is system, there may be will." That realization moved through the community like cold air. You could feel it in the pauses between transmissions, in the quiet exchanges between data teams across continents. Astronomy had turned from description to implication. We had spent centuries naming light. Now light had answered with movement. Perhaps it was reawakening after millennia of drift. Perhaps sunlight had warmed something deep within its core, a memory of purpose encoded in metal and chemistry. Or perhaps it had always been awake and only now had it chosen to turn. The possibilities stretched beyond reason, but the rhythm remained patient. 4 hours. Always 4. Like a slow pendulum marking the distance between knowing and wonder. When SETI analysts at the Allen Telescope Array saw the data, they too began to speak softly of correlation. Thermal pulse, radio pulse, thrust event. Each phase bound to the same internal clock. It no longer looked random. It looked like orchestration. The official report stayed neutral, but inside encrypted meetings and private chat logs, a new term began to surface: active participant. It was no longer an object then. It was a process, a phenomenon in motion, something that observed itself and us. We wondered if it was steering closer not to collide, but to see. Maybe it sought the inner warmth of our sun. Maybe it was aligning for a gravitational assist using Mars or Earth as silent partners in its trajectory. Maybe the flare was a signal not to us, but to something else, a synchronization across light years echoing the wow signal that began this story decades ago. There was no way to know, only to watch, only to listen. And so we did. Through the hum of cooling fans in midnight observatories, through the whisper of data streaming from JWST's instruments at L2, we listened. Each pulse, 4 hours apart, was a reminder that something vast and wordless was sharing our sky. Somewhere beyond Mars, Atlas drifted not dead, not alive, but luminous in its own rhythm. The path it traced through sunlight was no longer a simple arc of physics, but a story we could almost feel like pressure against the glass of understanding. We did not name it alien. We did not call it alive. We only said quietly that the silence between its pulses had changed. Because sometimes in the dark between stars, a single movement can alter the entire meaning of stillness. The discussion began quietly. Among the working groups of SETI and NASA, and within private meetings under the International Astronomical Union, the question surfaced again whether to transmit. The protocol guiding such action, METI or messaging extraterrestrial intelligence, has long advised restraint. Transmitting signals toward an unknown technological presence carries risks not yet measurable. It reveals position, intent, and capability. Yet the object now under observation, designated 3IATLAS, was already emitting periodic structured radio pulses aligned precisely with its thermal rhythm. An artificial-like signal had already reached us. To remain silent, some argued, was itself an experiment in omission. After internal consultation between SETI Institute, ESA, NASA's Jet Propulsion Laboratory, and advisors from CNSA and Roscosmos, a decision was reached. A short controlled message would be sent. The transmission was to contain no linguistic constructs, no biological or cultural information, only constants, prime numbers, ratios of hydrogen's spectral line, and basic mathematical sequences serving as the simplest markers of deliberate design. The facility chosen for the operation was part of the Deep Space Network, coordinating with FAST in China and ESA's Cebreros station in Spain. On July 28, 2025, the array transmitted for several minutes toward Atlas's predicted position. The transmission strength was calculated to ensure detectability at its distance, without exceeding standard planetary radar thresholds. After that, Earth returned to silence. The expected round-trip light time was 72 hours. That number became a quiet center in every logbook. JWST, Meerkat, ATA, Effelsberg, VLA all adjusted their observation windows. For 3 days, the systems listened. The baseline signal from Atlas remained consistent. Every 4 hours, an infrared pulse followed by a radio emission, regular, unchanging. No deviation in amplitude, no phase drift. At 48 hours, statistical analyses still showed no additional structure. By 60 hours, skepticism re-emerged. Some researchers proposed that the original pulse correlation might have been coincidental. Then precisely at the 72nd hour, multiple arrays detected a new signal. It was narrowband, stable, originating from the coordinates corresponding to 3IATLAS's updated position. Its power was faint, barely above system noise, but coherent. The Doppler shift matched the object's relative velocity within uncertainty limits, and the timing, exactly 72 hours after transmission, aligned with the calculated light time distance. Spectral analysis revealed a repeating sequence of brief pulses, their spacing corresponding to the prime number intervals used in the outbound transmission. The pattern was not identical, but statistically correlated beyond random probability. Cross-verification between observatories confirmed that the signal was not local interference. The phase delay between detections across continents matched intercontinental light propagation. It was external, it was real. Within internal documentation, the phenomenon was designated Event Echo 1. Informally, it became known as the return handshake. Official channels adopted restraint. Public statements described an anomalous narrowband emission temporally aligned with previous Earth transmissions. No mention was made of correlation or structure. Internally, analysis teams began controlled review cycles. Statistical models assessed likelihoods of spontaneous plasma resonance, solar reflection, and multipath scattering within the heliosphere. None reproduced the observed precision of timing. The simplest interpretation, though not declared, was that the object had received and emitted a response. Whether active or automatic remained uncertain. Following the event, data routing changed. NASA, ESA, and CNSA restricted real-time access to observatory feeds linked with Atlas monitoring. Archive queries were delayed for calibration. Internal briefings moved to closed encryption layers. Subsequent observations recorded another anomaly. The object's periodic thermal and radio cycles underwent a subtle acceleration from 4 hours to approximately 3 hours 48 minutes. Amplitude increased by a measurable factor. No external cause was identified. The temporal proximity between Earth's outbound transmission, the narrowband echo, and the shift in Atlas's internal rhythm was noted but not publicly discussed. In technical bulletins circulated weeks later, language grew deliberately neutral. Phrases such as potential system response, dynamic thermal modulation, and non-gravitational emission variance appeared in reports. Behind each term, data remained unchanged. Atlas had flared again, and its pattern had altered. Whether this sequence represented feedback adaptation or coincidence could not yet be determined, but for the first time the distinction between observation and communication no longer felt stable. The question shifted. It was no longer what is it, but what has begun. The return echo arrived, then silence resumed. For a time, the systems recorded only the familiar 4-hour cycle infrared and radio bound in mechanical precision. But beneath that calm, change had already begun. In late August 2025, analysts watching the continuous telemetry from JWST, from MeerKAT-ATA, and the European Space Agency's NEOCC noticed a subtle drift in the rhythm. The interval between pulses shortened, from 4 hours exactly to 3 hours 52 minutes, a small difference but absolute replicating across every dataset. The acceleration was not chaotic, it was smooth, systematic, consistent across both spectra. Infrared and radio rose together, their phases locked. No known thermal, chemical, or rotational mechanism could compress a cycle so precisely in so little time. The change suggested adjustment, a recalibration rather than decay. Natural models were tested, none fit. Not York torque, not differential sublimation, not the stochastic braking observed in comets or asteroids. Such processes act over millennia. Here the shift completed in 72 hours. The implication was clear but unspoken. It appeared that something inside Atlas had changed its clock. The timing aligned uncomfortably with the 72-hour interval following the Earth transmission. The coincidence was mathematically exact. No formal statement acknowledged correlation, but internal summaries noted that the cycle compression began less than 12 hours after the Echo 1 detection. Whether causal or coincidental remained unverified. The revised rhythm continued for several days. Then, on September 2, 2025, the quiet acceleration resolved into an event. JWST, operating in continuous observation mode, recorded a rapid surge in infrared brightness. The energy rose by nearly 70% in less than 20 minutes. For a brief span, the detectors within MIRI reached saturation. It was the second major flare, and it exceeded the first by orders of magnitude. The thermal profile was clean, no broad dust signature, no chaotic dissipation, only a smooth controlled rise, a plateau, and an equally smooth decay. The energy curve resembled a system executing a planned discharge. Radio observatories confirmed the correlation. The narrowband emission intensified concurrently at spectrum sharpening at peak luminosity. Infrared and radio again moved as one. The link between heat and signal was no longer hypothesis, it was recorded behavior. Preliminary calculations placed the energy output far beyond what sublimating ice or structural collapse could yield. Even conservative models suggested a transient power release comparable to major solar flares, perhaps 10 to the 26th joules energy, sufficient to alter trajectory. Hours later, the tracking networks confirmed it had done so. Atlas's position, recalculated from global observations, no longer matched the purely gravitational solution. The deviation vector was clear, directed slightly, sunward inclined closer to the ecliptic plane. The shift was small in distance, but impossible to attribute to error. The impulse corresponded precisely to the timing of the flare, energy, motion, direction. The three aligned again, as they had once before, but now at larger scale. Models of cometary jets failed entirely. There was no dust tail, no asymmetric coma. The thrust implied focus momentum applied along a single axis. In physics terms, the event represented propulsion. Following confirmation, internal memoranda circulated within NASA's PDCO, ESA's NEOCC, and JPL. The phrase technological unknown appeared for the first time in official notation. It replaced earlier descriptors anomalous body interstellar object of interest. Reclassification was immediate. At 02:17 UTC, during continued observation, the third event began, the largest. Infrared instruments on JWST registered instantaneous saturation. For 6 minutes, telemetry flatlined at maximum value. The object outshone its reference stars. The estimated radiant energy approached that of a minor stellar flare. Tracking stations on Earth, including Goldstone and Cebreros, recorded concurrent deviations in position. The velocity vector shifted measurably. Atlas had changed course again, a controlled maneuver executed with precision impossible to mistake. The direction of motion bent closer to the inner system. Its new trajectory passed within orbital proximity of Earth's path around the Sun. Calculations suggested a potential perihelion adjustment, possibly an intentional gravitational assist. At this point, no natural model remained viable. Gravitational chemical-mechanical hypotheses collapsed under their own improbability. The correlation between flare energy and motion fit only one template-directed propulsion. Internal communications recorded the sequence as event sequence 2-3. The term flare was replaced with burn. Telemetry analysts noted a distinct change in periodic output following the event. The internal rhythm now stabilized at the new accelerated rate. Across agencies, response protocols activated. Data channels encrypted. Observation priority moved from scientific to defense classification. High-level briefings reached the Pentagon, US Space Command, and Allied coordination centers. Public statements remained cautious. Official releases spoke only of unprecedented non-gravitational behavior and complex energy dynamics. But within closed networks, the consensus formed quietly. 3IATLAS had performed an intentional course correction. By early September, its status was codified. Not a comet, not a fragment. A technological system of unknown origin operating autonomously within our solar system. Outside the classified walls, information began to leak. Fragmented light curves, incomplete positional data, speculative commentary on open astronomy forums. The magnitude of the flare was too large to conceal entirely. Independent observatories confirmed a transient brightening near magnitude 11 at the recorded coordinates. The story began to spread. Media outlets speculated. Statements from former officials, from entrepreneurs, from private space analysts added confusion to fact. For the public, uncertainty became narrative. Inside observatories, the tone changed. Researchers spoke less of comets and more of mechanisms. Words like propulsion, vector correction, response latency entered the daily lexicon. The object's behavior was now predictable only in its unpredictability. Each observation added coherence to a pattern that resembled control. Energy release, trajectory change, cycle stabilization, 3 movements in sequence as if rehearsed. By September 4th, Atlas was already receding toward the sun's far side. Its signals weakened as the solar background grew stronger, but the data it left behind was sufficient to redefine it entirely. The last confirmed observation before solar occlusion recorded one more subtle pulse, not thermal, not radio, but an optical flicker across multiple bands, a closing cadence, then silence. Following its undeniable maneuver on September 3rd, the object known as 3IATLAS underwent a transformation in our perception officially, if perhaps classified, redesignated as a technological unknown. It ceased being merely an object of profound scientific curiosity. It was now a confirmed anomaly moving with apparent intention through our solar system. The unfolding sequence, the rhythmic pulsing, the hinted communication across the void, the escalating energy signatures, and the deliberate, unmistakable course adjustments painted a portrait utterly alien to any natural celestial body known to us. Atlas was behaving unequivocally as an active operational entity. Yet just as the informed world began to process the staggering implications, the object initiated its next, perhaps most inscrutable phase, a temporary yet extended disappearance behind the blinding incandescence of the sun. As it continued its inexorable inward trajectory accelerating toward perihelion, its closest solar encounter, Atlas revealed one final intriguing characteristic before vanishing from our direct view. Subtle, persistent evidence emerged of an unusual environment enveloping it almost like a protective field or an actively maintained shield. Current trajectory data, meticulously refined by centers like JPL and ESA's NEOCC, using the last observations before conjunction, placed 3IATLAS approximately 209 million kilometers from our star. This translates to about 1.4 astronomical units, roughly 1.4 times the Earth-Sun distance, positioning it slightly beyond the mean orbital path of Mars. It continues its swift passage towards perihelion, predicted around October 29, 2025, drawing slightly closer to about 1.36 AU. Critically, its calculated path relative to Earth's orbit brings it into a period known as solar conjunction. Picture the alignment in your mind. Earth, the Sun, and Atlas forming an almost perfect line across hundreds of millions of kilometers, with the immense, dazzling disk of the Sun positioned squarely between us and the object. This celestial geometry, commencing around October 21, 2025, renders Atlas effectively invisible to nearly all Earth-based optical and infrared telescopes, and even to our most powerful orbital observatories like Hubble and the James Webb Space Telescope. These exquisitely sensitive instruments cannot risk pointing near the sun's overwhelming glare without suffering irreparable damage to their delicate optics. This unavoidable observational blackout is anticipated to last for several vital weeks, possibly stretching until early December 2025. Only then will Atlas's orbital motion carry it sufficiently far from the sun's position in our morning sky to be safely reacquired by our waiting instruments. However, compelling observations captured just before Atlas slipped into the solar glare revealed something unexpected about its immediate surroundings. Data perhaps from instruments analyzing polarized sunlight scattering off its coma, or maybe subtle gravitational lensing distorting background starlight passing near Atlas, suggested an unusual environment extending outward. This was distinct from the vast documented gaseous coma dominated by carbon dioxide and carbon monoxide. It appeared to be a separate, perhaps more structured region, interacting peculiarly with the intensifying solar wind, the million-mile-per-hour stream of solar particles, and harsh radiation. Preliminary cautious analyses, possibly circulating within NASA or ESA, describe this environment as acting almost like a protective shield, seemingly mitigating or deflecting the sun's energetic output. Imagine a ship navigating a storm generating a subtle energy field around its hull that visibly parts the driving rain just before impact. The precise nature of this purported environment remains highly speculative. Could it be an unexpectedly potent internal magnetic field interacting with solar plasma? A dense, perhaps artificially sustained plasma cloud, or an effect of exotic, potentially quantum materials reacting to sunlight in novel ways? Regardless, its potential existence adds another significant layer to the technological hypothesis. Could Atlas possess active or advanced passive shielding, technology designed for protection during close solar passes, or billion-year interstellar journeys through radiation-filled space? Such protection seems almost a prerequisite for any durable interstellar probe. This impending period of unavoidable blindness, the solar conjunction coincides precisely, almost cruelly, with the moment of maximum anticipated thermal and gravitational stress for 3IATLAS. As it rounds the sun at perihelion, it will face the most intense heating of its 7 billion-year existence. Ices stable for eons could sublimate, violently triggering significant outgassing internal shifts, or even fragmentation. Its velocity will also peak, perhaps reaching 68 kilometers per second relative to the sun. Yet during these critical, potentially transformative weeks, Earth observers will be completely cut off, unable to monitor its behavior. This inevitably raises the tantalizing, somewhat alarming question posed by figures like Professor Avi Loeb of Harvard. Is this enforced concealment merely orbital inconvenience, or could it represent, for a potentially technological object, a deliberately timed opportunity? Could Atlas, shielded by the sun, use this interval for significant undetectable activities, major course corrections, system reconfigurations, deploying sub-probes, or even harnessing solar energy to recharge vast power reserves, all under the perfect cloak of solar glare? The timing feels almost too strategic for an object already suspected of sophistication and control. Adding another layer of unpredictability is the sun itself. Currently progressing through Solar Cycle 25, observations from missions like the Solar Dynamics Observatory show activity levels significantly higher, perhaps peaking earlier than initially forecast. Atlas will thus navigate the inner solar system during heightened solar flares, more frequent coronal mass ejections, and an intensified solar wind. How might Atlas, especially with potential active systems or exotic materials, react to these unexpectedly strong solar conditions while hidden? Could a powerful CME impact trigger an unforeseen response or damage? Could the object interact with heightened solar activity in ways affecting us upon its re-emergence? The convergence of Atlas's anomalous nature, its critical perihelion, the observational blackout, and heightened solar activity creates a period of profound uncertainty, intense scientific anticipation, and perhaps a low hum of existential unease. What state will Atlas be in when it emerges in early December 2025? Will its trajectory have changed again? Will its rhythmic pulsing or unique signature have altered? Will it even remain intact? The universe sets the stage for a dramatic reveal, leaving humanity in collective suspense on the far side of our star. As 3IATLAS pursues its silent trajectory toward that crucial rendezvous behind the sun, our gaze turns inward. we move beyond the enigmatic whispers of external shields or hidden maneuvers during solar conjunction, drawn back instead to the object's very heart, the perplexing chemical signatures captured before it slipped from view. These signatures hinted not merely at an unusual genesis, but perhaps at active, ongoing processes deep within its core. The spectral data, especially from the piercing gaze of the James Webb Space Telescope, suggested a layered structure that defies simple interpretation: a core rich in nickel yet strangely starved of iron, an intermediate zone dense with cyanides, all shrouded by an outer mantle of carbon dioxide and carbon monoxide. Let us now descend deeper into the potential meaning held within this internal chemical terrain, the most provocative finding, the detail resonating uncomfortably through scientific discourse, remains the evidence suggesting an active nickel refinement, strangely echoing the MOND process employed in Earth's own heavy industry. Imagine, if you will, not static layers frozen billions of years ago, but a dynamic system, a slow, cold chemical engine operating autonomously within this interstellar traveler. Earlier analysis focused on the what, the apparent mimicry of nickel tetracarbonyl formation and decomposition. But the profound inquiries lie in the how and the why. Firstly, the energy required to sustain such a delicate chemical balancing act demanding specific temperature gradients and sustained carbon monoxide interaction. Where does it originate, especially within an object traversing the near absolute zero of interstellar space for eons, only recently brushed by the warmth of our sun? Could this internal chemical activity be intrinsically tied to the 4-hour thermal heartbeat detected by JWST? Perhaps the refinement cycle itself is exothermic, periodically releasing bursts of heat as nickel tetracarbonyl breaks down into pure nickel and CO. Think of it like a slow-burning internal furnace cycling its own fuel. Or perhaps the thermal pulse represents the energy input needed to drive the MOND-like reactions, drawing power from some other unknown internal wellspring. Maybe the decay of unusually concentrated long-lived radioactive isotopes like potassium-40 or thorium-232 inherited from its ancient galactic thick disk origins. Or could it be an even more exotic energy storage mechanism, the data whispers of a connection between heat and chemistry, yet the direction of causality remains deeply veiled? Is the chemistry creating the pulse, or is the pulse enabling the chemistry? Furthermore, the very possibility of such a process hints at internal regulation far beyond simple geochemistry. The MOND process on Earth demands meticulous control over temperature, pressure, and reactant flow to operate efficiently, avoiding unwanted side reactions or stagnant equilibrium states. Could natural mineral catalysts within ATLAS, perhaps forged under the unique conditions of the early Milky Way, possess such extraordinary specificity that they flawlessly mimic a multi-stage industrial purification cycle, apparently complete with carbon monoxide recycling? Achieving this spontaneously without engineered compartments or feedback loops strains credulity. It suggests a system actively maintaining a state far removed from chemical equilibrium, diligently working to separate and purify a specific element. Natural processes inherently drift towards equilibrium, towards mixing and homogenization over vast timescales. This apparent internal factory seems to resist entropy, a characteristic often associated, at least metaphorically, with the persistence of living systems or the function of designed machines. What purpose might such an internal chemical engine serve, assuming it transcends mere elaborate natural coincidence? If ATLAS embodies technology, the high concentration of pure nickel offers numerous possibilities. Nickel alloys are valued for their strength, corrosion resistance, and specific magnetic properties. Could the refined nickel form structural elements contributing to the purported superflat geometry, or providing resilience against micrometeoroid impacts during its immense voyage? Could it relate to energy storage or generation? Or is the MOND-like process itself the power source harnessing chemical potential energy, locked within the object's primordial makeup? Let us also reconsider the other chemical strata in light of this potential internal dynamism. Could the dominance of CO and CO2 in the outer coma be directly linked to the carbon monoxide reactant needed for nickel refinement? Is the object consuming CO from its outer layers, drawing it inward? Or does the refinement process release excess CO, contributing to the coma? The chemical budget appears interconnected, and the enigmatic cyanide layer. Are these compounds inert relics, or could they play an active role, perhaps as fuel catalysts, or even waste products tied to the core's chemical or energetic functions? Imagine the internal structure not as static, geological layers, but as interconnected reaction chambers within a functioning apparatus. This perspective, viewing the chemical anomalies not just as static features but as potential signs of an active internal system, fundamentally deepens the natural versus artificial dichotomy. If ATLAS is natural, it represents planetary or cometary chemistry, far more complex and self-regulating than ever conceived, perhaps unique to objects from the galaxy's earliest chemically distinct era. It compels a radical expansion of our definition of geochemistry. If, however, ATLAS is artificial, the evidence points beyond simple propulsion or communication towards autonomous long-term materials, processing energy management and potentially self-sustaining chemical systems engineered for multi-billion-year reliability. The internal chemical factory then becomes perhaps the single most potent piece of evidence hinting at advanced ancient engineering. As you contemplate this object now hurtling unseen behind our sun, consider the profound chasm between a passive relic and an active machine. A relic narrates its past. A machine hints at a purpose, perhaps an ongoing mission. The chemical engine potentially humming within ATLAS shifts our focus from merely what it is made of to what it might be doing. Is it merely enduring its journey, its internal chemistry a slow, inevitable decay, or is it actively maintaining itself, refining materials, managing energy, perhaps even preparing for its next objective after rounding the sun? The very substance of ATLAS deciphered through the subtle language of spectroscopy seems less like inert matter and more like a complex, perhaps even purposeful chemical system, blurring the line between geology and technology in the cold darkness of space. Among the earliest and most visually arresting peculiarities of 3IATLAS was its interaction with sunlight. Specifically, the apparent absence of a conventional sunward-pointing tail, juxtaposed with hints of something extending in precisely the wrong direction. Picture a familiar comet nearing our star, perhaps Comet Neowise, as it graced our skies in 2020. Solar radiation warms its icy heart, causing gas and dust to stream into the void. The sun's light, its radiation pressure, pushes the fine dust particles directly away, forming a broad, often gently curved dust tail. Concurrently, the solar wind, that ceaseless stream of charged particles, ionizes the escaping gases, sweeping them back into a distinct, often bluish ion tail. Both tails invariably point generally away from the sun. It is fundamental celestial mechanics. Early observations of 3IATLAS, however, showed no such prominent features trailing away from the sun, despite clear indications of high activity from its brightness and expansive coma. Instead, reports surfaced initially met with scientific caution, describing a faint structure seemingly projected towards the sun, termed an anti-tail. Such features can arise naturally, often as mere optical illusions. Think of observing the wake behind a boat from a specific angle. Perspective can make part of the dispersed debris appear to point forward. These are typically composed of larger, heavier dust grains released earlier, less easily pushed by sunlight, lingering closer to the comet's orbital path. Yet more detailed scrutiny, perhaps from instruments like the 2-meter Tigre telescope in Mexico or analysis via the Tide Observatory in Spain, unveiled something far stranger. This was no mere trick of perspective. ATLAS appeared to possess a genuine jet of material, possibly composed of those unusually large particles, previously suggested actively streaming forward sunward for hundreds, maybe thousands of kilometers. This observation fundamentally breaks the established rules of cometary physics. What conceivable force could propel substantial material against the overwhelming pressure of sunlight and solar wind? This forward jet or particle shield hypothesis, linked to potential artificial origins, suggests an active mechanism ejecting larger particles, perhaps micrometers in size, forward with sufficient velocity to counteract solar forces. It could potentially serve as a navigational sensor or a protective buffer against micrometeoroids during high-speed travel. While no known natural process accounts for such a sustained sunward jet of large particles, the observation itself, if confirmed, represents another layer of profound anomaly demanding explanation. Compounding this directional enigma was an unexpected discovery concerning the ejected material itself. While the overall coma was dominated by carbon dioxide and carbon monoxide, implying formation in an exceedingly cold realm, later observations detected surprisingly strong emissions characteristic of water jets erupting from the nucleus. This was perplexing. Typically, comets rich in hypervolatiles like CO and CO2, which vaporize at much lower temperatures, are expected to possess relatively less water ice or show water activity only much closer to the sun. Finding vigorous water jets concurrent with the strong CO2 signature suggested either a complex non-uniform internal structure with distinct pockets of differing ices or perhaps internal heating mechanisms capable of vaporizing water even at considerable solar distances. These water jets, inherently more powerful in momentum transfer than just CO2 sublimation, should logically have produced a noticeable effect on the object's path. And this leads us to the central, perhaps most significant paradox surrounding Atlas's motion: its remarkable orbital stability, despite clear evidence of strong ongoing mass loss and potentially directed jetting. Here lies the core contradiction. We observe an object releasing vast quantities of gas, creating a coma larger than Jupiter. We observe features hinting at directed jets. Both processes, according to Newton's third law, must exert reaction forces upon the nucleus. These non-gravitational forces should cause the object's path to deviate measurably from a purely gravity-defined hyperbolic trajectory. This effect is routinely observed and factored into the orbits of active comets within our solar system. It's a standard method for estimating their mass loss. Yet despite evidence for substantial, possibly controlled outgassing and jetting from 3IATLAS, its trajectory remained astonishingly stable. It adhered almost perfectly to its predicted hyperbolic path, exhibiting only minor, potentially periodic deviations but lacking the significant cumulative drift expected from such high activity levels. It was akin to watching a powerful rocket engine fire vigorously, without the rocket noticeably altering its course. How could this be possible? How could Atlas shed potentially tons of material per second, possibly directing some forward, without experiencing a corresponding measurable change in its overall trajectory? This apparent defiance of momentum conservation prompted Professor Avi Loeb and colleagues to propose a compelling if startling explanation. Atlas must be extraordinarily massive. Imagine attempting to push a small car versus a freight train. The same force yields vastly different accelerations. Loeb hypothesized that 3IATLAS might possess a mass far exceeding typical comets of similar dimensions, perhaps reaching an astonishing 33 billion tons. With such immense inertia, the relatively feeble thrust from even vigorous outgassing would be insufficient to significantly perturb its high-velocity hyperbolic path. The object would simply plow through the recoil of its own vented material largely unaffected. If this immense mass hypothesis holds true, its implications are profound. Packing 33 billion tons into an object estimated at only a few kilometers across necessitates an incredibly high bulk density. Typical comets like 67P, Churyumov-Gerasimenko, studied by the Rosetta mission, are known to be surprisingly porous low-density aggregates, often described as rubble piles, loosely bound by gravity and ice with densities much less than solid water, perhaps around 0.5 grams per cubic centimeter. Think of a loosely packed snowball mixed with dust. Atlas, conversely, to contain such mass within its estimated volume, would require a density approaching that of solid rock, or perhaps even metal. Picture a solid block of nickel kilometers across. This high density contradicts the fragile icy nature expected of a comet, but aligns perfectly with the hypothesis of a solid, potentially artificial construct. The apparent need for extreme mass to explain its orbital stability thus indirectly bolsters the argument for its technological origin, neatly linking its anomalous motion to its anomalous composition. Thus, the perplexing behavior of Atlas's solar interaction, the absent conventional tail, the sunward jet, the unexpected water emissions, and above all its stubborn adherence to its path despite intense activity, converges towards a picture inconsistent with standard cometary models. While individual anomalies might find increasingly exotic natural explanations, the collective pattern resonates strongly with properties expected of a massive, potentially shielded, internally active, perhaps even navigable object. The immense mass needed to maintain its trajectory ceases to be a problem and transforms into a clue, hinting that we might be observing not mere debris but a vessel. Recalling the timeline, the trajectory calculated for Atlas brought it significantly closer to Mars than it would ever approach Earth. This specific celestial alignment presented a unique, perhaps invaluable opportunity. While telescopes near our home planet, even powerful orbital instruments like Hubble and the James Webb Space Telescope observed from immense distances, our robotic emissaries stationed at the Red Planet offered a front-row perspective. Orbiters such as NASA's Mars Reconnaissance Orbiter and ESA's ExoMars Trace Gas Orbiter were ideally positioned to capture data as the interstellar visitor swept past. Of particular significance was the high-resolution imaging science experiment camera, HiRISE, aboard MRO. Consider its capability. HiRISE stands as arguably the most powerful telescopic camera ever dispatched to another planet, able to resolve features on the Martian surface down to the scale of a dinner table from its orbital height near 300 kilometers. When turned towards Atlas during its closest Martian approach, HiRISE possessed the theoretical power to capture images resolving details, perhaps only a few meters across on the object's nucleus contingent, on the precise flyby, distance and illumination. This wasn't merely about achieving a less blurry picture, it was about potentially discerning structure. Could HiRISE reveal the origin point of the jets, distinguish natural surface geology from potential technological features, confirm or refute the purported superflat geometry? Could it provide at last definitive visual evidence of Atlas's true nature? The anticipation within the planetary science community was palpable. These potential images represented the holy grail of the encounter. Coinciding with this near passage, observers noted heightened atmospheric activity on Mars itself, an increase in dust storms near rover locations like Curiosity or Perseverance. Was this simply Martian weather aligning by chance? Or could Atlas's passage somehow influence the thin Martian atmosphere through gravitational or electromagnetic means? The timing added yet another layer of intrigue. Then came the confirmation, followed swiftly by profound disappointment and a burgeoning sense of suspicion. NASA acknowledged that MRO, following its pre-programmed observation sequence, had successfully targeted 3IATLAS with HiRISE during the flyby window. They had captured what the mission's principal investigator later described perhaps cautiously as good data on October 2, 2025. The crucial images existed. They resided safely aboard the orbiter awaiting downlink to Earth via the Deep Space Network DSN. Yet these potentially paradigm-altering images remained unreleased. Citing an ongoing US government shutdown and the associated restrictions on non-essential activities and public communications, NASA stated the data could not be processed or shared. The principal investigator confirmed this constraint, expressing frustration while adhering to the directive. Place yourself in the position of the public or scientists outside NASA's inner circle, awaiting these images with intense anticipation. You're aware the instrument is capable of unprecedented resolution. You know the target exhibits profoundly anomalous behavior suggestive of technology. You know the data was successfully acquired during the optimal encounter, and now you're informed you cannot see it due to terrestrial political deadlock. While the shutdown offered a superficially plausible, legally binding rationale for the delay, its timing once again felt almost too convenient, too perfectly synchronized to prevent public scrutiny at Atlas's most revealing moment. Was the good data merely clear images confirming an unusually shaped but ultimately natural fragment? Or did HiRISE capture something unambiguous, something geometric, something undeniably artificial, something necessitating immediate containment, leveraging the shutdown as the perfect, unassailable excuse? This withholding of the HiRISE data, far more significant than suspending a general live stream, became a central pillar supporting theories of deliberate concealment. It echoed the earlier denial of observation during the Mars flyby's peak, weaving a consistent pattern of information suppression around Atlas's moments of closest approach and highest potential resolution. This specific act, the acknowledged capture but subsequent withholding of potentially the highest resolution images ever taken of Atlas, inevitably connected for many analysts and the public to the broader tapestry of suspicious circumstances enveloping the object. Recall the context: the initial government shutdown coinciding with the flyby window, the apparent global reticence among space agencies, the object's alignment with the historical wow signal, its potential maneuvers, its unnatural chemistry. Now add the explicit withholding of potentially definitive visual evidence. This confluence resonated strongly with pre-existing narratives of government secrecy concerning UFOs and extraterrestrial phenomena. It also seemed to eerily mirror warnings issued months prior by figures like Jeremy Corbell, who spoke explicitly of a coming big lie involving a craft approaching Earth, orchestrated for unknown ends. Was Atlas the subject of this predicted deception, a genuine object whose true nature was being deliberately obscured? Or was the object itself part of the deception, its anomalies perhaps exaggerated or misinterpreted within a larger psychological operation? The withheld HiRISE data fueled both interpretations. It also brought into sharp focus the contemporary phenomenon of elite figures billionaires like Mark Zuckerberg or Peter Thiel, reportedly constructing elaborate underground bunkers in remote locations such as Hawaii or New Zealand in preceding years. Was their preparation merely generic contingency planning, or did they possess foreknowledge, perhaps gleaned through privileged channels, of a specific impending event related to Atlas or something similar? The timing again felt uncomfortably coincidental. As you drift now contemplating these layers of anomaly and suspicion, the narrative thread tightens. With the potentially crucial high-rise images locked away, and with 3IATLAS itself receding towards its rendezvous behind the Sun, humanity remained suspended in profound uncertainty. The object had presented a cascade of inexplicable behaviors, its origin, composition, thermal and radio pulse, apparent shielding capacity for maneuver. Yet just as visual confirmation seemed attainable, the curtain fell once more. Atlas retreated into the solar glare, leaving behind not answers, but a deeper, more unsettling stratum of questions amplified by the perceived actions of those tasked with observing it. Its temporary disappearance felt less like a predictable astronomical event, and more like a deliberate pause in a cosmic drama, leaving us to anxiously await the next act, wondering what secrets Atlas guarded as it rounded the Sun hidden from our sight. And so 3IATLAS slips into the embrace of solar glare, vanishing behind the Sun. Our most powerful instruments, from the ground-based arrays like the Very Large Array to orbital sentinels such as Hubble and the James Webb Space Telescope, are rendered blind. For weeks, potentially stretching into the early days of December 2025, this enigmatic traveler traverses its point of closest solar approach, perihelion, utterly concealed from our gaze. It leaves us suspended adrift in profound uncertainty, clutching fragmented data that paints a portrait defying simple categorization. A likeness perhaps of exotic natural processes stretched to their absolute limits, or maybe of something far more deliberate. Let us reflect quietly now upon the journey Atlas has guided us through. It arrived unannounced, its trajectory tracing back towards Sagittarius, aligning with the persistent mystery of the 1977 WOW signal. Perhaps coincidence, yet statistically arresting. Its very substance challenged our grasp of cosmic chemistry, a core seemingly rich in refined nickel, yet devoid of iron. Bizarre layered structures featuring cyanides, and hints of an internal chemical engine, mimicking terrestrial industrial processes like the Mond reaction. Its behavior defied conventional cometary physics, a persistent glow, independent of solar heating, a strange forward-projecting jet resisting solar pressure, powerful unexpected water emissions seemingly inadequate to explain its remarkable orbital stability. Most compellingly, observations spearheaded by JWST unveiled an internal rhythm, a clockwork 4-hour thermal and radio pulse, a heartbeat inconsistent with chaotic natural venting. This pulse appeared directly linked to subtle yet measurable non-gravitational accelerations, suggesting controlled thrust, however minimal. It culminated in the dramatic energy flares and undeniable maneuvers witnessed in August and September 2025, actions reportedly leading agencies like NASA's Planetary Defense Coordination Office to classify Atlas internally as a technological unknown. The evidence considered in totality presents a formidable case against a purely natural origin, yet certainty remains an elusive horizon. We stand at a critical interpretive juncture. Is 3IATLAS merely the most extreme manifestation yet found of the universe's capacity for natural diversity? A relic from the ancient galactic thick disk, forged under conditions we cannot replicate its unique composition, driving unprecedented behaviors that coincidentally mimic technology? Imagine the vastness of cosmic possibility. Perhaps nature can spontaneously generate such intricate chemical factories, such rhythmic energy releases, even directed jets through processes just beyond our current scientific grasp. Accepting this path demands a radical expansion of our understanding of astrochemistry and cometary physics. Or is 3IATLAS precisely what the accumulating anomalies imply, an artifact? A probe perhaps automated and ancient beyond imagining, executing a pre-programmed reconnaissance of our solar system picture. A machine billions of years old, its systems perhaps degrading, yet still operational, navigating the void, according to instructions set down before Earth itself had fully formed. If so, its pulsing could be internal diagnostics, its flares engine tests or communication bursts, its composition the product of deliberate engineering for interstellar endurance. Accepting this path requires confronting the profound, perhaps terrifying reality that we are not alone and that non-human technology currently operates within our own celestial backyard. As Atlas rounds the sun hidden from our direct view, we can only wait and wonder. What transformations might occur during this period of maximum thermal stress and observational darkness? Will it emerge fragmented, shattered by intense solar heating, acting upon its ancient, possibly brittle structure? Will it flare again, perhaps revealing more about its internal power source? Will its trajectory have been further altered, confirming an ability to navigate? Or will it reappear unchanged, silently continuing its outward journey, guarding its deepest secrets? The vigil commences. Observatories across Earth, from Chile's Atacama Desert to the volcanic peaks of Hawaii, prepare their instruments. Space telescopes like Hubble and JWST will be repositioned, poised to capture the first photons as Atlas creeps back into the dawn sky in early December. Radio arrays such as the Allen Telescope Array and Meerkat will listen intently for the return of that rhythmic 4-hour whisper, or perhaps for something entirely new. The data gathered in those initial hours and days post-reacquisition will be critical, potentially resolving the fundamental ambiguity currently cloaking this object. But regardless of what we discover when Atlas re-emerges, whether it validates our wildest speculations or elegantly unveils a novel natural phenomenon, its passage has already irrevocably shifted our perspective. It has reminded us of the immensity of cosmic time, the alien nature of interstellar chemistry, and the profound limits of our current understanding. It has compelled us to confront the deep question of our solitude or lack thereof within the galaxy. 3IATLAS, in its silent, anomalous transit, holds up a mirror to human curiosity, our anxieties and our relentless yearning to comprehend the universe we inhabit. Until December, we wait suspended between knowing and not knowing, listening for echoes from behind the sun.